Okay, so we're going to prove that if x and y are independent random variables, then the expected value of x times y is equal to the expected value of x times the expected value of y. And throughout this proof, I'm going to show you why x and y must be independent in order for this equation to be true, right? Okay, and also we're going to be using the definition of expected value, so I have the table out here, the joint probability function represented as a table here. So let's go ahead and start this proof. So the expected value of xy, remember, that's going to be the sum of all of these, right? Every single one of these times x times its respective x and its respective y, right? So it's the sum from j equals 1 to m, so that represents all the x's, right? And the sum from I equals 1 to n, those are representing all the y's, of x sub j times y sub I times the probability that x is equal to x sub j and y is equal to y sub I. Right? That's the sum. That's basically saying the sum of all of these, right? All of these and all of these times its respective x and its respective y. And of course times each respective probability. All right? So the reason why they need to be independent is because this is the probability that x is equal to x sub j and y is equal to y sub I. And whenever things are independent, we know the probability of their intersection is just this. So this will be the sum from j equals 1 to m, the sum from I equals 1 to n of x sub j, y sub I, times the probability that x is equal to x sub j, times the probability that y is equal to y sub I. So notice I was able to separate this intersection because they are independent. That's the definition of independence. And then, of course, I can rearrange this. So I can rearrange this as the sum from j equals 1 to m of x sub j times the probability that x is equal to x sub j times the sum from I equals 1 to n of y sub I times the probability that y is equal to y sub I. And, of course, this is the definition of expected value of x, and this is the definition of expected value of y, right? So this equals the expected value of x times the expected value of y. So we're able to show that the expected value of x times y is equal to the expected value of x times the expected value of y only when x and y are independent random variables. So that is our proof.